Alright folks, welcome to my video on the CDK TF, or the Cloud Developer Kit for Terraform. In this video I'm going to go over the CDK TF a little bit, how to work with it, and then give some of my thoughts at the end. So let's go ahead and get started. So the first thing we're going to do after we have the CDK TF CLI installed is we're going to make a new directory for our project. We're going to call this CDK-hello. We'll go into this directory and we'll initialize the CLI, which will bootstrap our project. We're going to run CDK TF init, which is going to bring us through a wizard. It'll ask us if we want to use Terraform Cloud, which we don't. So I'm going to type no here. And then it'll ask what programming language we're going to use. So we pick 2 for TypeScript, and now we can give the project a name and a description. And I like these defaults. I think they're pretty good for at least this video. Now it's going to go through the process of bootstrapping, and I'm going to skip this because it's really not that important. Okay, so here we are in our project. We can see that the bootstrap process has created a number of files for us. We have our package JSON, our package lock, tsconfig, of course our main TS, and our main JS. It also has a CDK TF JSON. So we can click in here and see a number of different things. So going into the help file, we can see different help things that we can do in this project. So we can run some npm commands. We can also use the CDK TF CLI to synthesize our project. One of the interesting things is that this actually just turns your code into JSON, which is machine readable, and under the hood, under what HashiCorp uses and the configuration language, it's really just reading as if it were JSON. Along, you see here a number of other different CLI options, including diff, deploy, destroy, which are pretty self-explanatory. I believe you can read. Moving on, we can see the here are our files, our main.ts, and in this main TS we can see this is actually the class in which we create our resources, just like if you were to have like a main.tf. This is a main.ts. So what are the things you need in a Terraform project? You need a provider, sometimes data sources, resources, and then of course outputs. That's really what usually is going to make a project work. So I'm going to fumble through this for a moment, and then I'm going to start writing my code. So first, let's go ahead and create a new AWS provider. And I know that it's going to need the scope construct scope, the name of the provider, which is AWS, and then some configuration. So the only piece of configuration you need in the AWS provider is the region, so I passed that along. And you can see that I don't have this imported into the project yet, so I'm going to go ahead and import it now. Import AWS provider from, and there's actually a root directory folder called .gin, which is the provider configuration that it downloaded when it bootstrapped. So now you can see all the different items that it needs to create this new provider. They got scope, ID, and config. So let's create a data source. This is going to be a simple project where we just create one EC2 instance. So I'm going to bring in the AMI data source, so I don't actually have to remember an AMI ID, which is something you should always do. And I gave it this scope. I gave it a name for the AMI, which is AMI, and then I'm going to look up some values. I'm going to look up some, pass in some filter parameters to get the correct AMI name that I want. So the owner, the most recent, and then a filter of name, and then values, which I'm going to put in like Amazon. So theoretically, this could get like an Amazon Linux AMI ID. Um, Moving on from there, I can take a look and see that I need to use this AMI, so I'm going to pass it into my EC2 instance with const EC2 new instance, and then I'm going to pass in the scope, the EC2 name of the EC2, and then of course I'm going to pass in the instance type T2 micro classic for these hello world examples, and then the AMI is going to be the AMI.id. But you're going to see that the AMI ID is actually can come back as a string or undefined. So we actually can work through this. HashiCorp has created a way to get through it by using a token property that you can bring in and use as string. And so you can import the token method, and it'll actually just assume it's a string, and you can use that property there. So now that we have that imported, now it's time to move on to the output. So new Terraform output, and again this scope, we'll give it an ID, and then we'll pass in the value of the output as the configuration. So value is ec2.id, and from there we have written our first CDK TF project. So we'll go ahead and save this. We'll pull up the terminal and run CDK TF synth. So this is going to synthesize this configuration. It's going to, one, compile it into JavaScript, and then two, it's going to convert it into a JSON file that can then be deployed. So at this point, you can actually deploy it with CDK-TF deploy, or you can go into this directory and deploy using Terraform plan and apply. And you can see I've got a Terraform configuration block, provider configuration block, and then of course my data source using those same filters I passed, and then an instance here that I created using the data source for the AMI ID and a T2 micro, which is pretty cool. And then followed by the output that it's going to need in order to interpolate that EC2 ID. All right, that's pretty cool and all, but I think that we can make this make this closer to a real project. So with my TypeScript projects, I like to have a source directory. I know a lot of folks do that. And so I'll just go ahead and move my files over here into my source directory. And from there, I will update my imports like so. And I gotta update a few other files, like the CDKTF now needs to run from the source directory, and the package JSON needs to be updated to the source directory, just like this. And with that, I think I'll be good to leave my code there. And let's do something a little bit more interesting. Let's move some of this data into additional files and import it. Again, another very common pattern in writing JavaScript. So I'm going to write this and move this over into my EC2 file, ec2.ts, and move this into a function like so. And I know I'm going to need to pass in a scope with the type of construct, which was available inside of the class, but now it's not available in this file. So I'll go ahead and pass it in here like that. And for the EC2, I'm going to go ahead and pass in the scope with construct also. But there's something else I already know. The AMI ID is not available to me. The AMI is not here, so I have to pass it into with the type of data AWS AMI. Now let me save that, format it, and now I see that I'm going to have my imports, so everything should be working as expected. Let me go ahead and export these functions so I can use them in my main TS. And now I think we're good to go. Back to the main TS and take a look at that. So I can come back here and change the name, change the to an actual function. Oh, okay, so I forgot here. I shouldn't name it just AMI. I should name it get AMI and create EC2 instance here. And I can pass in the scope there. But let me change this first. Create EC2, and I'll pass in the scope. I'll pass in the AMI, and back up here on get AMI, I'm passing in the scope. Now I need to import my um, update my imports like so, and do a little bit of cleanup for what I don't actually use anymore. And I should be good to come over here into the terminal and run CDK synth once again. All right, so synthesizing, and here we go. So it's actually created the CDK TF JSON file, which you'll notice will be pretty much identical to what we just did with the Terraform block, provider block, data source, resources with one EC2 instance, and then the outputs. But I think we can get a little bit more interesting with this. Um, why don't we go ahead and say let's dynamically create instances. So we'll create an object for instances, and it'll be a list of objects, and in it we'll give it a name. We'll say foo, and instance type we'll say T2 micro, and for the we'll do another one, and instead of foo we'll call it bar, and instead of micro we'll call it small, so that way we can update and have different instances be created dynamically. So for here we'll go ahead and say instances dot for each, and we'll say the element would be, the value would be instance, and go ahead and pass this in as if it were a for each, and we'll go ahead and bring in our EC2 inside of the for each. However, whenever we create this, I already know that the name is going to need to be dynamically created too, and we want to pass in that instance type to be there. So let me update the EC2 to also take the name. We'll say name string, instance type string, and we'll go ahead and update. This would be called name, and we'll just remove the hard-coded instance, and it'll take whatever is dynamically passed. All right, so here we go. A name, instance type, and it'll be passed in dynamically for each item in that object. All right, so now we need to update the Terraform output to dynamically be passed in also. So I'll include it in the for each, but I have to update the ID to take the instance name, so the instance.name. So we'll pass this in, instance.name, and we'll do underscore ID, and we should be good to go with this. So it'll dynamically pass it in with foo and bar. Now let's do the CDK synth one more time, and we'll see the output, the JSON file it creates. So closing this, opening up the JSON file, and we see we got their metadata, Terraform block, provider block, data source. Now under resources we see we have a foo instance, a bar instance, and then foo output and bar output. All right, so thank you so much. So what are my thoughts on the CDK TF? I personally think this is a pretty cool project. I'm excited to see where it goes. I understand why folks would want to use something like this. I think that there are some powerful use cases. For one, if your front end is running in TypeScript and your back end is running in TypeScript, then it might make sense for your infrastructure to run in TypeScript. I also recognize this isn't for everyone, but instead it's just another option. So I think most folks are going to stick with the HCL, which I think is robust and powerful. But I think there will be probably a niche use case here and there for something like this. One of the most powerful things I think about this is that it's not just like AWS. Like you actually have access to all the providers, GCP, template provider, null provider, Kubernetes provider. And so I think you actually have the ability to reach deep down and connect into those providers to do kind of interesting things that we've probably not even seen yet. Some of those things would be maybe even connecting your code logic into the Terraform configuration. So if your code is written and does one thing, then perhaps your Terraform configuration can be changed or updated based on that dynamically. But I think for the most part, most folks are going to stick with HCL. I wrote all this out and I recorded it and practiced, but I had to look up the documentation. I had to look up the API to see what it wanted. And so I don't think you're going to really get away from that. And because you had to look up the API, whether or not you go on the web page for the documentation or you look at the type and the strong typings to look to see what attributes it wants, what configuration it wants, you're still going to have to go look at that stuff because most people don't even know, with a few exceptions probably, what all configuration is needed. So at that point, unless you're doing something fancy, you might as well just stick with HCL. So anyways, let me know what you think. I'd love to hear from you. Leave a comment or shout out at me. Contact me on Twitter or LinkedIn or something. Yeah, thanks for listening. Take care. Bye.